So, now we will do position time relation, that is also called here displacement time relation. But see here, this relation is also for uniform acceleration. Suppose you have taken graph like this is your v in this axis and this is time in this axis 0. Graph is going like this is initial velocity u and this is final velocity v. This we can take point A, B, C and D and this is E. Now, we have to calculate displacement from this graph. So, as we have done previously here, so area, this whole area complete, area of the velocity time graph and with the basically time axis here, that gives the displacement. So, we can write here displacement is equal to area of BCE plus area of ABED. I have divided this figure into two parts, triangle plus rectangle, whole area I have written. That we can write displacement, I am giving the symbol S. So, I am writing here by S is equal to area of BCE, this is triangle. So, half into BE into CE plus ABED, that we can write AB into here AD. Now, put all these values, you know CE, this is change in velocity, that we can write V minus U. So, here we can take this S is equal to half BE, that is a time here. So, we can write T into V minus U plus here AB into AD, AB is equal to U. So, we can write U into T. So, here S is equal to, we can write UT plus half T into V minus U, already I have done, that is AT. So, here you can write AT. So, that is S is equal to UT plus half AT square. So, this is the relation between displacement and time. So, U is initial velocity, T is time and A is uniform acceleration. Now, similarly, we can get from the same graph velocity displacement relation. So, now just come to the velocity displacement relation. I am going to use the same graph here. So, the graph is same here and we can get here now velocity displacement relation. In the same thing is here, we have to calculate displacement. So, we can write here again displacement is equal to area of ABCD. I have taken complete trapezium here, area of ABCD. We can write S is equal to, this is AB plus CD, AB plus CD and some of the two parallel sides into height, that we can take BE divided by 2. Now, you know what is the value of AB, that is U. So, you can write S is equal to U plus V, CD is V divided by 2 into B is time. Now, from the first equation we will be writing the value of T here. So, we can get the new relation if we put the value of T here. We will be getting S is equal to U plus V divided by 2 into V minus U divided by A in place of T. So, we can write 2AS is equal to V square minus U square, or you can write V square is equal to U square plus 2AS. So, these are the three relations here. One is velocity time, another one is displacement time and third one is velocity displacement relation.